All right, let's do a few more examples. Now, when you're doing a limit like this, the first thing you want to do is plug the number in and see what you get. In the easy examples we did before, we plugged the number in, we got a number, and we're done. Well, on these examples down here, if we plug in the 3, let's see, this gives me a 0 on bottom, and it also gives me 9 minus 21 plus 12. So that's a 0 on top. So if you get 0 over 0, this is actually worth writing. If you get 0 over 0, what you need to do is simplify the expression. And then plug in again. So let's do that on this one. X goes to 3. Now, here's a nice thing. We need to factor this. The bottom factors into x minus 3, x plus 3. The thing is, since this is a 0 of this polynomial, we know 3 is going to be one of the zeros. So x minus 3 is going to be one of the things it factors into. Same for the top. It'll factor into x minus 3 and also x minus 4. So now we can cancel this. We can cancel the x minus 3 and the x minus 3, and we're left with this. The limit is x goes to 3 of x minus 4 over x plus 3. And now we can just plug in that number and we'll be done. 3 minus 4 is, well, I'll write it down because we're plugging in 3 for x. So I get, that's 3 minus 4 is negative 1, 3 plus 3 is 6, and that's my answer, 1/6. Now you might look at this and say, what's the difference in this function here and the original function we had up here? Well, there's only one difference. If you were to graph this function and this function, the original one would not be defined when x is 3. This one over here, though, is defined when x is 3. All right, let's do this next one. This next one is the limit as x goes to negative 4. It's drawn in kind of small there, but x is going to negative 4 of this expression. Now, if I plug in the negative 4, that's the first thing you want to do on all of these is plug in the number. If I plug it in, downstairs I get 16 minus 32 plus 16. I'll add 0. If I plug it in on top, I get 16, looks like negative 16, but it's 16 minus 28, or no, it's plus 28 minus 44. So this one's also 0 over 0. So let's factor it. Erase all this. So it's the limit as x goes to negative 4. Now we saw that negative 4, plugging it in, gives us 0, so we know that x plus 4 is going to be one of the things that these factor into. The bottom factors into x plus 4 times x plus 4. The top factors into x plus 4 times x minus 11. So I can cancel this with this, and I'm left with the limit as x goes to negative 4 of x minus 11 over x plus 4. So now I'll plug the number in again, but if I plug in the negative 4, I wind up with a 0 in the denominator. I get 0 down here, and upstairs I get 4 minus 11 is negative 7. So I get division by 0. So that tells me right off, this limit does not exist. Now, can we say anything more useful about it? Does it go to infinity or negative infinity? Well, we have to look at the two-sided limit. Honestly, I'm just going to look at the graph. That's the easiest way to see this. So let me pull up Desmos right quick. And let's see, what are we trying to graph? We're graphing this function. So let's see, we've got y equals x squared minus 7x minus 44 over x squared plus 8x plus 16. And we're interested in what happens at negative 4. Well, let's see, at negative 4 here, let me pull this up on the screen so it's nice and visible. Over here at negative 4, I'm going to put in x equals negative 4. That's our asymptote. If we get on the function and approach negative 4 from one side, it goes to negative infinity. If we approach from the other side, it goes to positive infinity. So we can't say anything more than just this does not exist. Now, had this been a one-sided limit, well, if it had been a one-sided limit instead of a two-sided limit, then if it had been approaching from the right, the answer would be negative infinity, and if it approached from the left, the answer would be positive infinity. Now, one more thing. Let's see. Nope, not one more thing. That's it for this example. Let's look at another one. This one right here, limit as x goes to 0 of this. Notice if you plug in the 0, you're going to get 0 over 0. So we've got to do something to simplify this. Now in the previous examples we factored. On this one we can't do that. At least not, well, no, we can't do that. So what we want to do here is rationalize. So what I want to do is multiply the top and bottom by the square root of x squared plus 4 plus 2. Now the reason for that is when we FOIL this out, it's going to work out nicely. When I FOIL the top, I get this times this, which that just gives me x squared plus 4. When I do the outside, I get, I'm going to bring this down here so I don't run out of room. When I do the outside, I get this times 2. When I do the inside, I get that times negative 2. When I do the last, I get minus 4. Now on the bottom, I'm not going to multiply this stuff out. I'm just going to leave it as x squared times square root of x squared plus 4 plus 2. And now I'm going to do a bunch of, I'm going to do some simplification on top. Notice that here I've got plus 4 and minus 4, so those cancel. I've also got plus 2 times this, minus 2 times that. So those cancel. So what I'm left with is on top, all I'm left with is x squared, and on bottom, all I'm left with is x squared times square root of x squared plus 4 plus 2. Now I can cancel these. And I'm not going to rewrite it. I'm just going to go ahead and plug in x into, or plug in 0 for x and what's still there. So up top there's just a 1, and downstairs there is a square root of 0 plus 4 plus 2. So this winds up giving me 1 over 2 plus 2, so 1/4, and that's my answer. And you know, if you want to, you can come over here on Desmos and graph it and see that this is what the limit is. right, if I graph y equals, let's see, square root of x squared plus 4 x squared plus 4 minus 2, all of that divided by x squared. Now look at what happens to this when x goes to 0. I need to zoom in because right now it looks almost like a line. But right here as we approach 0, yeah, it looks like we're getting pretty close to 1/4. But right here at 0, it's undefined. I managed to get it to say that a second ago. I can't seem to get it. There it is, 0 undefined. But you can look at the y-coordinate there and see that as you get close to 0, the y-coordinate gets close to 0.25. You might say, well, it says 0.25 up there, but that's just because of round-off error. If you zoom way in and come off of here a little bit, it's a little bit less than 0.25. All right. Let's look at this last example. On this one, if you plug in the 0, on top you get 0, and on bottom you also get 0. For this one, though, there's nothing to be factored or to rationalize. There are two ways we could approach this, though. One way is probably not very intuitive, but you actually could factor this into, you could treat this as a difference of two squares and factor it into 2t plus 1 minus 1 times 2t plus 1 plus 1. You could factor it out like that, and this would work, but that's probably not very intuitive. So instead, let's do this. Let's multiply this thing out on bottom. T goes to 0. On top, I've just got t. On bottom, if I square this out, I get 4t squared plus 4t plus 1. And then the minus 1 there. So I can cancel the minus 1s, the minus 1 and the plus 1. And I'm left with not infinity, t's going to 0. On top I've got t, and on bottom I've got 4t squared plus 4t. Now I can factor that. Limit as t goes to 0. Up top I've got t. Downstairs I can factor out a t and a 4. So I get 4t times t plus 1. And I can cancel the t's. And if I plug the 0 into what's left, I just get, there's the understood 1 on top. And downstairs there's 4 times 0 plus 1. So this one again is 1/4. All right, I think I'll stop this video here.